Imagine you are lying in bed, staring into the darkness, completely still. The room is silent until you hear it. A faint, high-pitched whine tracing a ragged circle just inches from your ear. In that exact moment, your heart rate spikes, your muscles tense, and your brain triggers an ancient, hardwired alarm system. You are being hunted. Right now, on this planet, there are over 110 trillion of these hunters. You are outnumbered by roughly 14,000 to 1. They weigh less than a single drop of rain, possess a brain the size of a grain of sand, and yet they are statistically the deadliest predators to ever exist, having killed more humans than all wars, famines, and natural disasters in recorded history combined.
How did an insect that you can crush with a single half-hearted slap become the undisputed apex predator of human history? And what exactly would happen to the world, to the ecosystems, and to you if you successfully pushed a button today that wiped every single one of them from the face of the earth? To understand your enemy, you must first understand the absolute perfection of its biological engineering. When you think of a mosquito, you likely picture a flying needle, a simple, irritating pest. But what is actually navigating the dark airspace of your bedroom is a highly tuned, multispectral stealth fighter. You cannot hide from it because it is not looking for you with its eyes. It is looking for the chemical exhaust of your life. When you exhale, you release a plume of carbon dioxide. To a female mosquito, because only the females require the protein in your blood to develop their eggs, that invisible cloud of gas is a glowing highway. She is equipped with highly sensitive receptors on her maxillary palps that can detect carbon dioxide from over 50 feet away. As she follows this plume, flying in a zigzag pattern to stay within the highest concentration of the gas, she gets closer to you. At a distance of about 30 feet, her secondary targeting systems come online. She begins to read your thermal signature. Your body radiates heat, and her antennae are tuned to the exact infrared frequency of a warm-blooded mammal. Once she is within just a few feet, she switches to her short-range chemical sensors. She is now analyzing the exact biological makeup of your skin. She can taste the lactic acid pooling in your sweat, the uric acid, the ammonia, and the specific cocktail of bacteria living on your ankles and wrists. This brings us to a harsh biological truth. You will never, in your entire life, be able to hold your breath long enough or stay perfectly still enough to become invisible to a hunting female mosquito. Even if you stop breathing, your skin will continually broadcast your location across the room through heat and chemical vapor. Write in the comments the most extreme location you have ever traveled to where mosquitoes completely ruined your day. When she finally lands on your skin, you feel nothing. This is because her landing gear is designed to distribute her microscopic weight perfectly, and her mouthparts are a marvel of surgical precision. She does not just stab you with a single syringe. Her proboscis is a complex fleshy sheath called the labium, which houses 6 distinct microscopic tools. When she presses against your arm, the labium pulls back like a protective sleeve. First, 2 microscopic serrated blades called maxillae saw through your skin tissue. They vibrate rapidly, cutting through your cells with so little friction that your nerve endings barely register the damage. Next, 2 mandibles act as retractors, holding your tissue apart to keep the wound open. Then comes the labrum, the actual needle, which probes through the open wound, searching blindly in the dark for a blood vessel. Once it strikes oil, it acts as a highly efficient pump. But there is a final critical tool, the hypopharynx. As she draws your blood, she simultaneously spits her saliva down this second tube into your bloodstream. This saliva is a biochemical masterpiece. It contains a potent cocktail of anticoagulants to prevent your blood from clotting while she feeds, and local anesthetics to numb the area. By the time your immune system recognizes the foreign proteins in her saliva and triggers the histamine response that causes the itchy red bump, she is already gone. She has taken 3 times her body weight in your blood, and she has taken off. Her flight mechanics are equally astounding. If a raindrop hits a mosquito in mid-air, it is equivalent to a human being struck by a fast-moving school bus. Yet, they survive. They are so light that they simply merge with the raindrop, riding it toward the ground before using their water-repellent microhairs to peel themselves off and resume flight. They are nature's ultimate survivors, perfectly adapted to exploit the most abundant resource on the planet, you. However, the true danger of the mosquito does not come from the insect itself. A mosquito cannot kill you with its bite alone. The nightmare begins when you realize that this perfect surgical instrument is completely unsterilized, and it acts as the ultimate biological transport system for the most ruthless pathogens on the planet. The dark side of this biological marvel is its role as a vector. When a mosquito feeds on an infected host, she inadvertently draws up microscopic assassins, viruses and parasites that have evolved for millions of years, specifically to exploit her feeding habits. These pathogens survive the mosquito's digestive tract, replicate inside her body, and eventually migrate to her salivary glands, waiting patiently for her next meal. Consider the sheer scale of the devastation. This tiny insect is one of the leading causes of animal-borne deaths in the world. It is the primary delivery system for malaria, dengue fever, yellow fever, Zika, and West Nile. Hundreds of millions of people are infected every single year. The economic and physical toll on human civilization is almost incalculable. What makes this relationship genuinely terrifying is that some pathogens actively manipulate the mosquito's biology to maximize their chances of infecting you. For example, when certain parasites enter the mosquito, they hijack her nervous system. During the parasite's incubation phase, it actually suppresses the mosquito's appetite, preventing her from taking risky flights while the pathogen is still developing. But the moment the parasite is fully mature and loaded into her salivary glands, it flips a switch in her brain. The mosquito becomes ravenously, uncontrollably hungry. Furthermore, the pathogen actively damages the mosquito's feeding tubes, making it difficult for her to draw a full meal of blood. Because she cannot get full, she is forced to bite multiple hosts in a single night, frantically spreading the disease to as many people as possible in her desperate attempt to feed. It is a brutally efficient, deeply manipulative cycle of transmission. The mosquito is as much a victim of these pathogens as you are, serving as an unwitting, airborne hypodermic needle for nature's deadliest microscopic killers. While I strongly encourage you to consult official medical literature for precise data on these pathogens, the reality of the mosquito's impact on global health is universally acknowledged as catastrophic. Given this horrifying resume, your immediate instinct is likely a desire to eradicate them entirely. But if you look beyond the fraction of mosquitoes that crave your blood, you will uncover a hidden, foundational role that they play in the intricate machinery of the natural world. First, you must understand that blood is exclusively a female requirement, and only during her reproductive cycle. For the vast majority of their lives, and for the entirety of a male mosquito's life, they are strict vegetarians. Their primary source of energy is plant nectar. Because there are trillions of them visiting flowers every single day, mosquitoes are actually critical pollinators. There are specific plant species that rely almost entirely on mosquitoes for their survival. For example, the blunt-leaved orchid, found in dense, damp forests, emits a specific scent that mimics human body odor to intentionally attract mosquitoes. As the mosquito feeds on the orchid's nectar,
Pollen attaches to its eyes and head, which it then carries to the next flower. If you removed mosquitoes from the equation, a cascade of botanical failures would begin in wetlands across the globe.
Write in the comments if you knew male mosquitoes were strictly vegetarians before watching this video. Beyond the flowers, mosquitoes represent a colossal structural pillar of the global food chain in the form of pure, flying biomass. To understand this, you must look at the Arctic tundra. I have read countless case studies documenting the ecological explosion that occurs in the far north during the brief summer thaw. When the ice melts, it leaves behind millions of shallow, stagnant pools of water. These pools become the breeding grounds for staggering swarms of mosquitoes. They form clouds so dense they can actually block out the sun and asphyxiate larger animals. But these massive swarms are not just a nuisance, they are an all-you-can-eat buffet. Every year, millions of migratory birds travel thousands of miles to the Arctic specifically to breed. They make this exhausting journey for one reason: the infinite supply of protein provided by mosquito swarms. The birds gorge on adult mosquitoes, feeding them to their chicks, allowing for rapid growth before the winter returns. Furthermore, before a mosquito ever takes to the air, it spends its larval stage underwater. These wriggling larvae are ferocious filter feeders, consuming algae, organic detritus, and bacteria, essentially cleaning stagnant water systems. In doing so, they convert microscopic organic matter into a dense, meaty package that is then devoured by fish, frogs, dragonfly nymphs, and aquatic beetles. They pull nutrients from the microscopic world and package it for the macroscopic world. They are the great converters of the ecosystem, taking the smallest bits of energy and pushing it up the food chain to the animals you actually like. If you trace the timeline of human civilization, you will find that the mosquito has not merely been a bystander. It has actively rewritten the borders of empires, dictated the outcomes of wars, and shaped global economies. You might think that human history is driven by kings, generals, and conquerors, but time and again, humanity's greatest ambitions have been utterly crushed by this fragile insect. Consider the mighty Roman Empire. The city of Rome was famously protected by the Pontine Marshes, a massive, stagnant wetland stretching south of the city. For centuries, foreign armies attempting to march on Rome found themselves bogged down in these swamps, only to be decimated by invisible, airborne armies of mosquitoes carrying devastating strains of malaria. The mosquito served as Rome's ultimate biological defense system, a shield that no human army could penetrate without suffering catastrophic losses. But this sword cut both ways. When Rome's infrastructure began to crumble, the malaria spread into the local population, contributing significantly to the weakening and eventual collapse of the empire. I was frankly astounded to review the historical records regarding the birth of Great Britain. In the late 1690s, the independent nation of Scotland launched the Darien Scheme. They invested nearly a quarter of all the money in their entire country to establish a massive colonial trading hub in what is now Panama. They wanted to control the flow of wealth between the Atlantic and the Pacific. It was a brilliant economic plan, but they failed to account for the local residents. Within months of arriving in the jungle, the Scottish colonists were swarmed. Yellow fever and malaria, delivered relentlessly by native mosquitoes, annihilated the settlers. The mortality rate was horrifying. The colony was abandoned, and Scotland was left completely bankrupt. Financially ruined and desperate, the Scottish Parliament was forced into the Act of Union in 1707 with England, legally merging the two nations to create Great Britain. A mosquito effectively erased a nation's independence. Even the creation of the modern world map bears their bite marks. When the French first attempted to build the Panama Canal in the late 1800s, they brought the finest engineering minds and heavy machinery of the era. But they were defeated not by the earth or the rock, but by the mosquito. Tens of thousands of workers died from vector-borne diseases.
forcing the French to abandon the project in disgrace. The canal was only successfully completed decades later by the Americans after massive, unprecedented mosquito eradication campaigns were deployed in the jungle. During the American Revolution, British forces in the southern colonies were crippled by malaria, finding themselves entirely unprepared for the sheer density of infected mosquitoes in the swamps of the Carolinas, a factor that heavily influenced their eventual surrender. You cannot look at a map of the modern world without seeing borders that were drawn or erased by the feeding habits of this microscopic predator.
So, knowing the destruction they have caused, what would actually happen if you could snap your fingers right now and cause all 110 trillion mosquitoes to simply vanish into thin air? What is the real-world domino effect of their total disappearance? In the first week, the immediate sensation for humanity would be overwhelming relief. You could sit on your porch at dusk in the middle of summer without slapping your arms. Rates of new global disease infections would plummet overnight. But in the wild, an eerie silence would begin to fall. In the stagnant ponds, the lakes, and the marshes, the water would begin to cloud. Without the billions of mosquito larvae acting as filter feeders, algae and bacteria would bloom unchecked. The smallest fish, the frogs, and the salamanders, waking up hungry, would suddenly find their primary food source completely gone. By the first season, the collapse would move out of the water and into the air. As spring turns to summer, the great migrations would begin. Millions of birds would arrive in the Arctic tundra, exhausted and starving, ready to feast on the mosquito blooms that have sustained them for millennia. But they would find nothing. Without this massive influx of high-density protein, bird populations would face a catastrophic caloric deficit. Chick mortality would skyrocket. Entire generations of migratory birds, like the snowbunting and the Lapland longspur, would be severely decimated. Simultaneously, deep in the forests, the specialized orchids and countless other wetland plants that rely on the male mosquito for pollination would simply fail to seed. Write in the comments which animal you think would step up to replace mosquitoes in the food chain if they vanished. Many years later, the natural world would eventually rebalance. Nature abhors a vacuum, and eventually other insects, like midges or black flies, might evolve to fill the ecological niche. However, the most profound and terrifying change would not be what happens to the animals, it would be what happens to us. For thousands of years, the dense, mosquito-infested jungles of the Amazon, the Congo Basin, and Southeast Asia have been heavily guarded by this insect. The mosquito has acted as a brutal biological fence, keeping massive human populations from settling deep within the rainforests due to the absolute certainty of contracting deadly diseases. If you remove the mosquito, you remove the fence. Without the threat of vector-borne illnesses, human expansion into the last great wildernesses on Earth would explode. We would pave, log, and colonize the remaining tropical rainforests with unprecedented speed. The erasure of the mosquito would inadvertently trigger the rapid acceleration of global deforestation, hastening the destruction of the Earth's lungs. The very creature that has hunted you for centuries is also, paradoxically, one of the greatest protectors of the Earth's most vital ecosystems. Because the mosquito has been a constant, inescapable companion to humanity since our earliest ancestors stood upright, it has embedded itself deeply into our culture, our language, and our folklore. You can find traces of its irritating presence in almost every corner of human expression. Linguistically, the word mosquito itself tells a story of persistent annoyance. It stems from the Spanish and Portuguese word for little fly, derived from the Latin musca. When Spanish explorers first navigated the swamps of the Americas, they found an insect so dense and relentless, they simply named it the ultimate omnipresent fly. In the mythologies of the world, the mosquito is rarely revered. It is almost always depicted as a punishment or a born antagonist. If you look at the folklore of the indigenous peoples of the Pacific Northwest, such as the Tlingit and Haida, you will find a fascinating origin story. They tell the legend of a towering, man-eating giant who terrorized the coastal tribes. The giant was incredibly difficult to kill, possessing skin like stone. Eventually, a brave hunter managed to trick the giant and throw him into a massive fire. As the giant burned, he swore that he would continue to feast on human blood forever, even in death. When the hunter stirred the ashes of the fire, the embers flew into the air, transformed into a cloud of tiny, winged insects, and immediately began to bite him. According to the myth, the mosquito is the literal, undying spite of a man-eater, forever fulfilling its promise to drink human blood. In modern culture, the mosquito has become the universal idiom for disproportionate annoyance. We use phrases like using a sledgehammer to crack a mosquito to describe a massive overreaction to a tiny problem. It is a symbol in nearly every society of the small, persistent forces that drain our energy. Across all borders, languages, and belief systems, the mosquito unites humanity in a very rare shared experience, the universal, frustrated slap in the dark. So we return to the question you faced as you lay in the dark. How did an insect you can easily crush become the undisputed apex predator of human history? And what would happen if you squashed every last one of them? They dominate because they are the ultimate biological opportunists. They do not rely on brute strength, sharp claws, or venom. Instead, they weaponize our own biology against us. They use our breath to find us, our heat to target us, and our blood to breed. They are the perfect, frictionless bridge between the microscopic world of pathogens and the macroscopic world of human civilization. And if you were to press that button and erase them from existence, you wouldn't just be removing a pest. You would be pulling a foundational block out of the global food chain, starving countless species, and tearing down the invisible biological fences that protect the world's most critical rainforests from our own endless expansion. Understanding this complex, ancient relationship doesn't mean you have to cease reacting instinctively. When you hear that high-pitched whine in your ear tonight, you should absolutely still swing your hand, defend your blood. But as you do, you can at least harbor a grudging respect for the magnificent, terrifying, and essential biological machine that you are fighting. You are engaging in a war that has lasted for millions of years against the most successful hunter this planet has ever produced. If you want to continue exploring the brilliant and brutal realities of the natural world with me, hit that subscribe button right now. There is always another microscopic monster waiting in the dark, and we are going to shine a light on every single one of them.